I'm Stephen Foskett, organizer of Tech Field Day, and we are here in Austin, Texas, with a group of international delegates who've come in to learn and discuss and ask questions and interact during this technical presentation. You're about to hear from Uila, which is a new company to this audience, and I know that there will be a lot of discussion. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can also go to youtube.com/techfieldday to see more videos like this.
Demo 3 is about virtual networking, right? The common issues and challenges people face in the virtualized networking. So I'm going to switch to browser again. The screen I want to highlight is this one. Okay, this is the networking analysis view, right? And nowadays, people they pay attention to their physical networking, right? They upgrade their physical networking to be 10 gig, 100 gig, and that's fine. But for most of cases, they ignore the physical networking, right? This is the page we can fill the gap a little bit, because physical inside of your virtual networking, a lot of issues can happening. A typical one is virtual packet job. And of course, you have a lot of TCP layer networking issues like retransmission, zero window, reset, that type of thing. And this screen can help you, capture the problem, inside of your virtual networking. So a little bit interpretation of this graph. If you draw a line over here, the two columns at the left-hand side is part of your virtual physical networking, including top-of-rack switch and host. On the right-hand side, there's DV switch, vSwitch, port group, VMs, right? Those are your virtual networking. And as you can see, all the ribbons coming from your physical network down to VM level, and they all converge into different classifier. This is the first benefit of this graph. So by glancing through the classifier column, the
classifier is the application.
Application protocol.
Sometimes we call it classifier, but confuse some people. It's actually application. This is how we do deep packet analysis and analyze.
Yeah, they are coming from the deep packet analysis. And very quickly, what kind of application, what kind of traffic is running in your data center. Nowadays, you always find out some, strange stuff, strange activity inside of your virtual networking. So this is a good way, quick way for you to find out that part of information. Other than that, this graphic is very useful for you to design your networking. This is something actually we learned from a real customer. They just rolled out a web service, which consists of 10 web server, and there's the frontier load balancer, right? And during the peak time, they expect to see the traffic workload to be distributed evenly across the 10 web server. But they use this graphics and focused on that time. It turned out not to be the case, right? Then it prompted them to change the design and make the traffic allocation more evenly distributed across all the VMs. So they address this kind of networking design issues. Other than that, if you want to go deeper, you can pick a bar, pick an entity, and the tooltip pop up telling you all kinds of good networking statistics, like network round trip time, TCP retries, zero window, and reset. For this case, the network response time is the problem, right? It's orange. If you want to take a look at the trend, the fluctuations, you can go to the stats browser. The reason I come here is this is an interesting finding we identify in our lab. I'm going to show you how it looks like. It turned out to be let me focus on this one first. Okay, scroll down. I want you to focus on the network round trip time, right? You see the pattern over here. And you switch back to CPU, and you saw the pattern over here. For you to compare these two patterns, I'm going to switch back to the slides. Sorry about that. It's going to be easier for you. As you can see, the network round trip time pattern matched very well with the CPU usage pattern. And plus, the CPU ready, whenever CPU ready is shooting high, it pushed up the network round trip time. So it turned out to be a long network round trip time caused by the CPU issue, right? The long network round trip time is actually the symptom, not the root cause. The root cause is in your CPU health. That's a conclusion, an interesting finding we find out. A couple other slides I want to share with you. This is a case study from the real world situation. This customer have 2 Exchange server, right? One is running on host 1, the other one is running on host 2. And their end user always complain at some time, during the afternoon, their email server slowed down. And at the beginning, he suspected it's something related to the end user on the client side, but it turns out to be the virtual packet drop on the host level. So look at the trend on the top. This matched well with his expectation. Every afternoon, the application response time gradually increase, right? And if you look at the networking level, there's no long network round trip time. On the VM level, nothing suspicious. But on the host level, if you pay attention to this small square, which happened to be orange, he quickly realized there's a lot of virtual packet drop on that host. And he quickly decided to move his Exchange server to another host. Then nobody complained. Everything performed very well since then. Another slide is also from the same customer. I haven't touched this one during our during our live demo, but our picture looks almost the same like this one. So basically, this is the way we illustrate the VM cross-talking. Who's talking to who? On the first row, each VM or devices light up as a bar. The bar could be smaller, could be bigger, depends on the bandwidth usage. And more interesting thing for the customer is he quickly identified these two devices like a big octopus, right? It has so many legs, connecting to different VM, different devices. It looks very suspicious to him because at the beginning he believed these two are switches or routers, right? But he quickly checked the MAC address. He couldn't find them, right? That made him a little bit nervous. So that's why this kind of the way we lay out the information in such transparent way is very helpful for this kind of customer. They quickly realize what is right, what is wrong, what is strange, what is familiar, right? From there, they can doing remediation or fix the problem, right? I think this is the end of my demo. I'm gonna give it back to Chachi.
Well, we're running out of time, but I just want to conclude very quickly on the networking demo, because nowadays in the data center, it's all fast switches, right? So networking really isn't an issue or isn't a major issue for virtualized data center. But we continue to want to bring networking into the data center, especially for the monitoring tool, for several reasons. One is virtual networking is going on in there. And there is virtual packet drop in the virtual switches, which everybody ignores and does happen a lot. It is one of the key way of us demonstrating our value to our customer. We identify that very quickly. People are so surprised by virtual switch dropping packet. A lot of times it's because your VM had obsolete driver, not the vSwitch issue, but nevertheless, the end result is virtual packet drop. But that's one value that we bring in. But if you look forward a little bit, the reason why we push networking so hard in monitoring virtualized data center are twofolds. Number one is we're going to a virtualized world, right? Virtualized networking. You're going to have your virtual gateway, virtual firewall, software-defined networking, software-defined data center. You have automatically created data center with firewall that's so dynamic, it's so virtual, that your typical networking gear to monitor on virtual firewall, virtual switches, and virtual router, virtual gateway is going to be a whole different paradigm, right? Have to be living inside the virtualization layer. That's what we come into play. And especially when we talk about micro-segmentation, you need to pull your existing huge hairball of every service into different micro-segmentation. How do you put it apart? You need to know how they are put together today. And that's what we do. by providing the screenshot that Roger demonstrated. The application topology is like this, so you can pull that out this way. Or networking, this guy is serving all these guys, you pull it this way, right? So microsegmentation in that way is something that we actually provides a lot of value as well. So that's number one that we keep on pushing networking to monitoring data center. Secondly is networking, even though it's not the most troublesome area for data center internal, it actually provides a great view into your data center. For example, the traffic flow, right? People will look at that to say, hey, I, being a virtualization server guy, I don't expect my networking traffic or any traffic, data traffic, to be like this pattern. It always brings up interesting point to them. Just like application topology that we do, it's always interesting to them when you show them the flow. Oh, all my traffic is going to this physical switches and everything is carried by this virtual switches and going through this server. Well, am I serving this application? I don't think so, but usually they are surprised, right? But our flow kind of demonstrating that to give the kind of the insight into their data center. And secondly is detailed networking. The TCP Windows 0 indicating a server is not able to accepting more data. It's not a networking issue, it's a server application issue. TCP resets that we highlight a lot, meaning the server is rejecting client traffic, is not a networking issue, it's a server issue, it shows up in networking, right? And then all these type of things, network delay, Roger demonstrated, network delay times high is why? It's your CPU ready times high. You're being swapped out so much that your network's so bad. So networking is not a problem, it's a symptom, it's an indicator of other things that's more important. That's why bringing in networking view into the entire data center, especially in light of virtual networking getting bigger and more important, is something that I think we're so differentiated from others. And we think it'll make the, again, our slogan of full stack visibility more interesting to monitoring the new era of virtualized data center. So with that